Good morning, ladies and gentlemen. Welcome to the cosine rule. I'd like to start off by explaining the logic of it, then we'll go through what the rule is and a couple of examples. Essentially, if we have a right angle triangle, we know that we can label it A, B, and C, and then we can say that C squared is equal to A squared plus B squared with a right angle. Now, it sort of makes sense that if we make that right angle instead an acute angle, and once again we're labeling it A, B, and C, then C squared is equal to A squared plus B squared minus a bit. Similarly, if we make it obtuse, A, B, C, C squared will equal to A squared plus B squared plus a little. Now, essentially, the cosine rule is this add-on or takeoff at the end that adjusts for the fact we no longer have a right angle. The proof of the rule is beyond the course, but if you're interested, it's on that link there. And this is the rule. There are two versions of it. Well, really the same rule, but for angles and for sides. This one here is for sides. There are three different versions for which side you're aiming for, either A, B, or C. Once again, our normal labeling conventions apply. Or, from rearranging those equations, we can find what cos A, cos B, and cos C are. Alright, so, finding the unknown side. Now note here, if I hadn't told you this was cosine rule at the start, a very logical place is to try and find sine rule, or use the sine rule. So, with sine rule, we'd say, well, we have half a pair, and then the issue is we don't have another pair. So, sine rule doesn't work here. What does work is when we have an angle and two sides we know, we can use cosine rule. So I might label this corner here A, which means this is little a, B, C, B, C. Alright, I am looking for A, which means I will use the version of the equation highlighted here because it has A squared by itself. Good place to start is writing the equation down. A squared equals B squared plus C squared. Take 2BC cos A. A squared is equal to 10 squared plus 12 squared minus 2 times 10 times 12 times cos 62. X squared is equal to the result of that, which you can put in your calculator. Now note, at this stage here, we can just go cas. However, as before with sine rule, it's good to have the working down to show all the steps. And it turns out x squared is 131.33. Now, it's worth looking at that and thinking, well, is that the length of the side? Because quite often people stop there. Now, importantly, that's not the length of the side, clearly, because we have a 12 and a 10, so that can't be 133, that's insane. Instead, we have to say, well, x is equal to the square root of 131.33. X is equal to square root, shift answer, 11.46. Alright, unknown angle. Alright, once again, let me just show you what happened if you tried to use sine rule. Sine rule, you have half a pair, and then you look for another pair. Thing is, we don't have any, and we don't have any, so therefore, sine rule doesn't work. We're using cosine rule. Once again, start by labeling the sides. This one's already labeled little angle A, side A, B, C, B, C. Alright, since we're after angle A, we'll use this version of the rule here, where cosine of A equals B squared plus C squared take A squared over 2BC. And sub in. Note we can use this when we've got three sides wanting to find an angle. Cos A equals B squared is 19 squared plus 9 squared take 16 squared over 2 times 16, that's a lie, 2 times 19, sub these in very carefully, 19 times 9. Cos A is equal to 0.544. Now, clearly, that's not what the angle is. To get the angle, we must say A is equal to inverse cos of 0.544. A is equal to inverse cos of the answer is 57 degrees. Now, note, you can also see the working written out as this. So from here, you might see that A is equal to cos inverse 19 squared plus 9 squared takes 16 squared over 2 times 19 times 16. And it would be that sort of thing you would see in a multiple choice exam, where given options for A, they give you a whole series of different cosine rule ones, and you have to pick which one has the right numbers in the right space, for example. Alright, thus ends the video for today. Thank you very much.